So this is now part 2 of 3.3, I believe, yes. Okay, so we are now on to part 2. Now here, we have to recall some things from grade 9, like what like terms are. So like terms are two or more terms with the exact same variables with the exact same exponents. Like terms are important because we can combine them to simplify big polynomials. So here, if we can go to the next page, we can see these are like terms. So 2x and negative 7x are like terms because they both have x. Negative 8x squared and 3x squared are like terms because they both have the same variable with the exact same exponent. Okay? Recognize over here, these are not like terms, so these are unlike terms because 8x squared and x are not like terms. Okay? So you can see kind of a few examples here. Why is this important? Because we can combine like terms. So let's look at example 2 here. Identify the like terms in the following expression. Once identified, combine like terms. So first thing you want to do is look at this and say, okay, where are my like terms? Remember what like terms are. They are the things with the exact same variables with the exact same exponents. So this one's a little easy to see. X and y and x and y. Those are the exact same variables with the exact same exponents. So I'm going to highlight these as similar exponents. And I'm actually going to write them down. So this is 4xy plus 8xy. Okay. Now, where else is there similar terms? So here we have x squared. This guy has x squared. Remember, multiplication is commutative. So it doesn't matter which order you multiply these things by, it all is the same thing. So order doesn't matter as long as you have the same variables with the same exponents. So x squared, y cubed, z to the power of 1, z to the power of 1. So these things are like terms. Okay, and I'm going to write those in a different way, but this is minus 3x squared y cubed z minus 2y cubed x squared z. And then finally, of course, these are technically like terms because they have the exact same thing going on, right? They're both just constants. So minus 45 plus 2. So we can combine these. What does it mean by combine? Well, if you have like terms or like variables, you can simply just add their coefficients. So 4 plus 8, which gives me 12xy. So this turns into 12xy. Then we can focus over here. Negative 3 minus 2. That's going to give us negative 5, and then their variables are just going to follow along. And then finally, negative 45 plus 2 gives me minus 43. So there is your simplified polynomial up here. So this thing equals this expression. Okay, we just made it simpler. Now, why is this useful? It's useful because we need to know how to expand things. So last video we talked about factoring, which can be very difficult, especially if you don't practice. So make sure you're practicing. But now we want to know how to expand things. So let's look over something before we move forward. We should remember how to multiply two terms. So multiplying variables means you add exponents. So if you have the same variables, so like x times x, which is right here actually, x multiplying x, well this is x to the power of 1 times x to the power of 1. When you multiply variables, you add their exponents. So these little exponents we're just going to add. So this will turn into x to the power of 1 plus 1, which is x squared. Okay, and you guys probably know that x times x equals x squared, but it's because you're actually multiplying or adding the exponents. So here, let's simplify this. Remember, everything in here is multiplying, so we can move things around within the multiplication. So here, I'm going to make these z squared times z cubed right beside each other. Then I'm going to put my y values right next to each other. So y to the power of 1 times y squared. Or sorry, y to the power of 4. And then my x is just a loner. He's just going to be by himself, times x. So here I have two similar variables, so I'm going to add their exponents. So this will be 2 plus 3, which gives me z to the power of 5. Okay. Here I have y to the power of 1 times y to the power of 4. Well, then you add their exponents. 1 plus 4 equals 5. So this is y to the power of 5. And then my x is a loner again. He's not going to do too much. He's just going to stay the same. So this simplified is x to the power of 5, or sorry, z to the power of 5. My bad. Z to the power of 5 times y to the power of 5 times x. So we can represent this simplified as this expression here. Okay. Now, kind of similar, and we should know how to do this already, but to multiply these two things together again, multiply the same variables and multiply the numbers. So here, I'm going to do, whoops, I don't know why it does that sometimes, just hang on. Here, I'm going to combine my coefficients, so negative 2 times 8. Negative 2 times 8, and then I have x squared times x. Then I have y. I just have y on its own actually, so this will be times y. Z and z, so times z times z, and then w there. So negative 2 times 8 is negative 16. X squared times x, remember, add their exponents, so I can see a little 1 here. So that'll be 2 plus 1 is 3, so x cubed. Y doesn't change. Z times z, well that's z to the power of 1 to the power of 1. So we'll add their exponents. So that's z squared times w. And there is our simplified expression. Okay. So this is useful because we need to know how to expand things. So remember how we factored stuff out in our part 1 video? Well, we have to know how to go from this to this. Okay, and it's not overly difficult. What's going to be done is sometimes we're going to be asked to multiply a polynomial back into the brackets. When expanding a polynomial, it is critical to understand that you're expected to multiply the number outside the brackets by every term inside your brackets. Okay, so here, what does that mean? We have some term outside our brackets, and we need to multiply by every single term inside. Okay, so how do I keep track of that? Well, I'm going to bring this, and I'm going to distribute inside. So this is called the distributive property. Sorry, I spelled that totally wrong. That should say distributive. Okay, the distributive property. Think about what distributing something means. Amazon distributes packages all throughout the world. You could see each term being a little home, and then this guy on the outside being a Amazon delivery guy, and he's delivering all the packages to each home. So here, to distribute inside, I'm going to multiply negative 2x by x squared plus, and then I'm going to multiply negative 2x by positive 4y. So this will be negative 2x multiplying 4y. So now you can hopefully see why we had to review some. Remember, you're multiplying the same variables, you add their exponents. So this will be 1 plus 2. So negative 2x cubed plus negative 2 times 4 is negative 8. So I'm going to put brackets around that. And then my x and my y can't really mingle. You can't do anything about that, so it's just going to be xy. And this is going to be negative 2x cubed. And I'm going to combine a positive and a negative, make a negative. So this will simply be minus 8xy. So that's a lot more clean. Okay, now why would we do this? let's see here. Let's make x equal 1 and y equal 2. Okay, and I'm going to use this expression here. So negative 2 times, and I'm going to make my x 1. So these x is 1. So negative 2 times 1, multiplying 1 squared plus 4, and then my y is 2, so 2. Okay, so I've plugged in x and y into this. And that will give me negative 2. This is positive 8. Negative 2 times 9. So negative 18. Okay, let me just double check that. Now recognize I could also use this expression. Negative 2 times x, which in this case is 1 cubed, minus 8 times x, which is 1, times y, which is 2. And let's simplify that. So 1 cubed is 1 times negative 2 is negative 2, so that doesn't change. 8 times 1 times 2, well, that's 16, so this would be minus 16. Give me negative 18. So it looks like everything worked out. Okay. Now, you should be able to see that we could use either expression here. So we both got negative 18, so that's why we can say that this equals this. Okay. Now here, let's focus on this guy. So remember, this actually isn't very hard to expand because we actually don't have anything to add to. So here, we're not having to do this, the distributive property. This again is just multiplying all these numbers. So you can see that when you have brackets, you got to bring it inside, and then when you have brackets but you don't have multiplication, well, you only have one term to multiply the outside term by. So this will be negative 5 times 10, which is negative 50, okay? X squared times x cubed, which is found right here, x squared times x cubed. That gives me x to the power of 5. And then you have z times z, that gives me z squared. And then multiplying y. So we didn't really have to do too much there. Let's maybe do one more example here, because I feel like I might have missed something to add to that. So let's do example 3 over here. So let's expand, and let's do something a little bit easier. 2xy squared multiplying negative 3x plus 4. Okay, so again, I need to multiply every term inside the brackets. So here I will get negative 2xy squared multiplying negative 3x. So this will be 2xy squared multiplying negative 3x plus negative 2xy squared multiplying 4. And then from there, we can combine these. So 2 times negative 3 gives me negative 6. X times x, remember, you add their exponents, so that would be x squared because it's 1 plus 1. And then my y value doesn't change. 2 times 4, that gives me 8. And here, my values will just stay because they're not multiplying any other thing. So there's no other x or no other y to multiply by. And there we have simplified the expression. So now go check your understanding with 3.3. Again,